Hi all. In this video, we will discuss about how to pass structure to a function. We can pass structure to function in three ways. First one is passing individual data members as arguments. Individual data members of structure as arguments. Second one is passing entire structure, name of the structure as argument to function. Third one is passing address of structure to the function. Second one comes under call by value category. Third one comes under call by reference thing. Now we will discuss these three techniques by taking one program. So that is uh, perform perform complex number addition. Complex number addition. So now we will take program on this one. So first one is first way of sending structure to function is passing individual data members of structure as arguments. So first I am declaring one structure, defining one structure. So here complex structure I am taking. So any complex number contains real value uh, and imaginary value. So these two I am taking as data members of structure complex. Now I have to declare a function. This function I am taking as a function name as add, and this function is returning a void parameter. So void add. So in the first case, individual data member I have to send. I am taking four integer arguments. Why I am taking four integer arguments? To perform complex number addition, I require two complex numbers. So real value of first complex number, imaginary value of first complex number, two arguments. Next one, real value of first complex number and imaginary value of second complex number. Now here you see, so real values of two complex numbers we are sending, imaginary value of two complex numbers we are sending. So first I have to declare complex structure variables. I'm taking A, B are my complex structure variables. A is one complex structure variable, B is another complex structure variable. So first we have to read A data and B data. So enter A values. So that means we have to read real value of A complex number and imaginary value of A complex number. That is A dot RE. So here A is our complex variable, structure complex variable, and RE is the data members of that particular structure. To access data members of structure by using a structure variable, we have to use dot operator as accessing operator. So that is we are reading a complex number. Next, we have to read B complex number. Next, we have to read B complex number. That is, so scanf, same thing we have to use percentage D, and ampersand B dot RE, comma, ampersand B dot IM. Now, I'm calling function add by sending these four values, that is A complex number, real value and imaginary value, B complex number, real value and imaginary value. So that is my main function. So here this subfunction is not returning anything. That's why we are taking the return type of that function as a void. So here, how many values I have to take? How many formal parameters I have to take? Four formal parameters. All those four as integer values, integer variables. Now, here you observe A dot real number is assigned to X, A dot imaginary is assigned to Y, B complex number real number is assigned to Z, B complex number imaginary is assigned to W. So now here I am declaring one new complex structure variable, that is C, where I am going to store result. Now what I have to add? X plus, so X contains A dot real number, Z contains B dot real number. Next one is imaginary case. Y contains A dot imaginary plus W contains B dot imaginary. Now we have to print this result. So percentage D plus I percentage D. What we have to print? C dot real number comma C dot imaginary. So return. This function is not returning anything, just we are using return. So observe this one. This is the first way of sending data, sending structured data to the function. I am sending individual structured data members as arguments. So here I am writing program to perform complex number addition. So two complex structure variables I am taking A, B. First I am reading A complex number, A dot real value and imaginary value. Similarly, we are reading B complex number, real and imaginary. So here data members I am sending separately, A dot real number, B dot A dot imaginary, B dot real, B dot imaginary. Once I call this function, this one is a function calling. Once I call this function, control goes here. A dot real number is assigned to X, A dot imaginary is assigned to Y, B dot real number is assigned to Z, B dot imaginary is assigned to W. Now here I am taking new complex variable C. C dot real number equal to X, okay, so which is A dot real number, Z, that is B dot real number. Those two are adding. Next, C dot imaginary is A dot imaginary plus B dot imaginary. Y contains A dot imaginary, W contains B dot imaginary. Those two we are adding. After that, we are printing a C complex number. Like this, we can write program passing structure to function, individual data members of structure to function. So now we will see execution of this particular program. A values, first A real number is 1, A imaginary number is 2. B values, real value of B is 3, imaginary value of B is 4. Now my result complex number is 4 plus I 6. So like that we can perform addition of two complex numbers by sending individual data members of structure as arguments to function. Now we will see second one, that is passing entire structure to the function. In that case, our formal arguments are changes. What we have to send? Two complex numbers we have to send. So struct complex, comma, two complex structures I have to send. Struct complex. So this is my function declaration. So my function name is add. I'm sending two complex numbers. This function is not returning anything. So I'm sending two complex numbers means what I have to send. What are my two complex numbers? A is one complex number. B is another complex number. A comma B. So at the receiving place, what is the modification I have to do? So struct complex X. X is my new formal parameter thing. So that is X and Y. So here, what I have to take here, X dot RE plus Y dot RE. Similarly, here we have to perform X dot IM, imaginary number, Y dot IM. Observe here, in this case, what are the changes we are doing? This is our second case. That is passing entire structure to this function. Same program, complex number addition program. So I am defining my complex structure. This is my function declaration. I'm sending two complex numbers, two complex structures. So struct complex and struct complex. In the main function, I am declaring two structure variables, A comma B. So A is one complex structure, B is another complex structure. Here, for A, we are reading the data. Real value of A, imaginary value of A. Next, we are reading B complex number. Real value of B and imaginary value of B. We are calling the function with two complex number sending as actual parameters A, B. Now, A complex number is assigned to X, B complex number is assigned to Y. So now X is my formal parameter, Y also my formal parameter. Inside this subfunction, I am declaring one more structure variable, that is a C. C dot RE equal to X dot RE plus Y dot RE. Those two real numbers we are adding and we are storing that one in C dot RE. Next, X dot real imaginary number plus Y dot imaginary number we are assigning to C dot IM. We are printing that. Like this, we can write program to pass entire structure to a function. Now we'll see execution of this particular program. So enter A structure values. Real number is 1, imaginary value is 2. Next, B complex number, real value is 3, imaginary value is 4. Observe the result, 4 plus I 6. That is a second way of sending structure to function. Next, last one is sending address of structure to the function. If you are sending address of the structure to the function, how to receive as what we have to use as formal parameter? We have to use pointer. If you are sending address, you have to receive with pointer. So struct complex star. Next one is struct complex star. What are you sending? You are sending address of A structure and you are sending address of B structure. Now what we are taking here? We are taking pointers to this structure. Okay. Now what is the modification here I have to do? X arrow RE Y arrow RE. Dot operator is used to access data members of the structure in the case of ordinary structure variable. Arrow operator is used to access data members of structure by using pointer to structure. Now, what is happening here? You observe this is the third case, passing address of structure to the function. We are defining the structure. Next one is function declaration case. We are taking a pointer to the structure. So now in the main function, we are declaring two structured variables, reading A data and reading B data. What you are sending? You are sending address of A structure. That address is assigned to X. Okay, now you observe here that A address of A is assigned to X. What is X? X is a pointer to struct complex. So both types are same. Then only we can assign address. So X equal to ampersand A. Now B address is assigned to Y. So that is Y equal to ampersand B. Now X contains address of A, Y contains address of B. By using this pointer, if you want to access data members of the structure, we have to use array operator. So observe here, C dot RE equal to X dot RE plus Y dot R, sorry, X arrow RE plus Y arrow RE. C dot IM equal to X arrow IM plus Y arrow IM because X and Y point at two structures. Now we are printing this resultant complex number. Like this, you can send address of the structure and at the receiving place by using pointer you can receive. So that is third way of sending structure to the function, that is address of structure to the function. Now we will see execution of this program. Okay, so reading A values 1 and 2. 1 is real number, 2 is imaginary number. Reading B values 3 and 4. 3 is real number, 4 is imaginary number. Observe the result, 4 plus I6. So like this, you can send a structure to the function. So in brief, you want to pass one structure to the function, we have three ways. One is passing individual data members of structure as arguments. Second one is passing name of the structure as argument to the function. Third one is address of structure to the function. So generally, passing of individual data members of structure is not advisable to use. Second one, that is passing name of the structure to the function is similar to call by value. Third one is sending address of structure to the function is similar to our call by reference. Thank you.